This is Wireless Energy Transfer, a look into staying connected without the connections, by Team 4, Robert Paul, Frank Garrick, Dave Howard, and Trent Mortensen. Wireless power actually has a history. The thought of wireless power has actually been around for some time. Nikola Tesla originated the idea way back in 1899. He was actually able to transmit 100 million volts of high-frequency electric power wirelessly over 26 miles to a bank, which lit up 26 bulbs and one electric motor. The Power Tower. No, that's not a name of a cheerleading move. It was actually a tower created to generate power wirelessly over the globe. The project was backed by J.P. Morgan, but funds were withdrawn and never finished. One night, an MIT professor became annoyed with his beeping cell phone due to a drained battery. He thought, with all this energy in my home, why can't this phone charge itself? In 2007, Marin Soyachich and his assistants successfully made the first efficient non-radiative power transfer at a distance of 2 meters, turning on a 60-watt light bulb. Energy transfer was at 40% efficiency. Professor Soyachich's experiments and work in wireless energy transfer are related in the spirit to the work of Nikola Tesla. The Soyachich group focuses only on short-range transfer. This work is being pursued in Soyachich's Witricity company. Soyachich believes that low-power commercial application of this technology, such as charging of mobile phones, is only several years away.
What are the different methods for producing wireless power? Wireless power can be classified into short-range, mid-range, and long-range transfer. Let's talk about short-range first, which is usually done through a method called inductive coupling. Ever use one of these? If you have, you've used short-range energy transfer. Next time you use your electric toothbrush, check out the bottom. No exposed metal connections. Here's how it works. When electricity travels through a straight wire, it produces a somewhat weak, circular magnetic field around the wire. Now if you wind the wire into a coil and pass an alternating current through it, a stronger magnetic field is produced. Now if you place another coil within the magnetic field of the first coil, a current is produced in the second wire which can be used to power a load that is attached to the second coil. See this light bulb being lit without any wires? This is inductive coupling. So the next time you put your electric toothbrush back on the charger, check it out, no direct electrical connection. Now let's talk about mid-range energy transfer. Since a magnetic field spreads in all directions with inductive coupling, this is only practical for short distances. In 2006, researchers at MIT found that the distance of wireless power could be extended by adding resonance to inductive coupling. The idea is to have a curved wire coil that has two plates on the ends with a gap between them. The plates hold a charge, and as electricity passes through the wire begins to resonate at a frequency dependent both on the wire and the plates. When a coil with the same resonant frequency is within range of the first coil, energy can pass between them. Energy can pass to several coils at once and at a distance of a few meters. Since energy is not spread in all directions, hence it is called non-radiative energy transfer, it is a more efficient method of wireless energy transfer. Finally, let's talk about long-range energy transfer, which is on the order of miles. We will discuss a method of doing this using microwaves that are converted to electricity. In the 1980s, Canadian researchers used this technology to power a small airplane that would fly at an altitude of 13 miles and fly in circles 2 miles in diameter. This plane could fly for months. Long-range microwave power transfer involves transmitting microwaves to rectifying antennas. These antennas convert microwaves into direct current. David Criswell from the University of Houston has proposed using this technology to beam energy to Earth from moon-based solar panels. However, space-based energy transfer is only theoretical at this time. So what are the applications for wireless power? Short-range applications include chargers for small electronic devices such as cell phones, cameras, and toothbrushes, as mentioned earlier. Energizer and Duracell currently sell wireless charging pads that charge electronics simply by placing the electronics on the pad. Mid-range applications include the powering of laptop computers, TVs, radio frequency identification tags, and medical equipment and devices. Possibly one of the most promising applications is the wireless charging of electric car batteries, such as has been developed by New Zealand-based Halo IPT. Depending on economic conditions, possible applications of long-range energy transfer include the transmission of power from satellites to several Earth-based receivers, providing a clean source of energy.
So what are the advantages and disadvantages of wireless power? First, wires suck. Duh, winning. Just think of not having to run wires everywhere in the home or workplace, or walking to your home and having your cell phone charge automatically. Next, if we could transmit electricity wirelessly and efficiently long distances, think of the impact on the environment due to the saved resources. Wireless energy transfer can penetrate building materials and wrap around obstacles in order to provide energy. Next, this stuff is safe, so you're not going to grow a third arm. This is a non-radiative mode of energy transfer generated through a magnetic field. Magnetic fields have been known to interact weakly with humans and animals. Wireless energy is scalable from milliwatts to kilowatts, so the flexible geometry allows it to be embedded in a host of different applications. What are some of the disadvantages? This stuff is expensive. There's a high capital cost in developing and implementing this technology. There's also interference with present communication systems in which we currently use. The range and efficiency of this technology has not been mastered.
So who is using wireless power today? We already mentioned cell phone charging pads and electric toothbrushes. PowerCast is a company specializing in wireless radio frequency power transmission. They use this technology to power RFID tags for industrial monitors and supply chain tracking. The Department of Defense already uses these RFID tags widely. They're superior to traditional RFID tags in that they do not require replacement when the batteries die. The electric car market is also getting increasingly interesting. Witricity specializes in magnetic resonance wireless power transfer. They are working with Mitsubishi to develop a wireless charging system for electric cars. Evitran is a Virginia-based company that has already developed a power mat for electric cars and has a partnership with Sears, where Sears will install the system for you. It is not currently available, but there is a waiting list for the first of these systems, and production is expected to begin in the next few months. The Evitran plugless power system will retail for around $3,000. Hertz, the rental car agency, has already partnered with Evitran in a plugless power pilot program, where Hertz will pilot a few of Evitran's charging systems with electric cars in their U.S. fleet. Qualcomm is another company looking to enter the wireless charging market for electric cars. Qualcomm purchased an Australian company named Halo IPT late last year. Halo IPT had also developed a wireless charging system for electric cars, and Qualcomm now has an agreement to establish a 50-car wireless charging trial in London this year. The question then becomes, how will this technology affect the market in the next few years? We've discussed the need for a better battery in class, but if this technology becomes fairly cost-effective, we may see the need for batteries in some applications diminished or eliminated. Another electric car application currently being explored is in the use of electric car charging systems embedded into roadways to eliminate the range problems that electric cars encounter. Essentially, the car would be recharging as you drive. But due to the cost of wireless charging systems, this is unlikely to be cost-effective in the near future. Some car makers are currently working on integrating the PowerMet technology into the interior of their cars, so owners can easily recharge their phones while driving. Also, we're likely to start seeing this technology more commonly integrated into small electronics like cell phones, laptops, and tablets. HP and Nokia are both working on integrating wireless charging technology into products in the near future. Another area that is being developed is medical devices. Currently, electronically powered medical device implants frequently require a wire that connects to an external battery. This increases the patient's risk for infection. Some companies are looking at powering medical devices wirelessly to decrease potential complications. We could also see more low-power devices like wireless mice, keyboards, remote controls, and wireless game controllers becoming increasingly batteryless. Some already are. PowerCast is currently working on the development of a wireless power system for HVAC systems that might be seen in the next few years. The same technology could also be used for powering or recharging wall clocks, carbon monoxide detectors, sprinkler systems, and smoke alarms.